This is section 4.2, video number 1. And to begin with, I want to give you what I call the number story. And it's a snapshot of essentially all the different kinds of numbers that you're going to be using this year and a little peek into what's going to happen in the future. So I kind of tell this story like a story. And imagine back in the days of the caveman and cave person. And if you were in your cave with your rocks and counting your rocks, what is the first number you would need to learn? Well, that would be the number 1 and 2 and 3 and 4 and 5. Those are called the natural numbers. And they're the natural numbers because they naturally are what people will start to use when they need to use numbers. 1, 2, 3, and obviously that goes up to infinity, right? Now, I want you to imagine then that you get a neighbor who's a caveman, cave person, and this person comes and steals all your rocks. Now, what number do you need to add to this list that's not there? Well, I go with the number 0. And if you take all of these numbers and you add to it the number 0, you have what are called whole numbers. So whole numbers encompass these, but also add the number 0. So whole numbers are all of these. And then the ice age comes and it gets cold. So it's cold outside, we need negative numbers to talk about the temperature. And those are called integers. And integers are all of these numbers plus negative numbers. So the way I'm going to write negative numbers are negative 4, negative 3, negative 2, negative 1, and then 0 and 1 and 2 and 3 and 4, and so on. And those are called integers. And then you develop tools because you're sitting inside your cave bored because you can't go outside because it's blizzarding, and you take your rocks and you break them into little pieces. So what kind of numbers do you need now? We need decimals, you need fractions. Talk about half of your rock or a quarter of your rock. These are called rational numbers. Now, rational numbers are negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Now, those aren't fractions, or are they? They are, because you could write them technically as over 1. Or if you were looking at them as decimals and you're looking at them as money, well, this is exactly $1, 1.00, 2.00, 3.00. But rational numbers also include fractions like 2/5 or negative 4/9, or any other fraction that has a number on the top and bottom that themselves are both integers. We could also have decimals, 2.7, 2.78. Decimals that end or repeat, 2.5, are all considered rational numbers. Now, if somebody or a number is rational, they look like this. What's the opposite of a rational number? Well, that would be an irrational number. And an irrational number is not going to be part of this group here because they're a little out there. Irrational numbers have decimals that never end or never repeat. Now, where do those numbers come from? Well, I'm going to go back over here and I'm going to add a few. A natural number or a whole number or integer or rational number, they can have roots in them, like the square root of 9, which is 3. But irrational numbers come from roots that don't have nice answers, like the square root of 7 or the square root of 11 or our good old friend pi. All of these numbers, if you punch them into your calculator, will have decimals that fill up the calculator screen, but they don't end there. They continue forever, and they don't have a repeating pattern, and they don't ever end, which is why they're called irrational. Now I'm going to jump ahead a little bit and go beyond what we're actually going to talk about this year, just so you can see a snapshot of what all occurs. These numbers here, all together, the rational and the irrational, are all called real numbers because they all really exist. Pi, for all its strangeness, exists, and we use it a lot. We use it as much as we use the number 3 or -4 or 2/5. These are all called real numbers. Looking ahead, we're actually going to have numbers in the world that are not real. And so out here, just to let you know what happens, we're going to have things called imaginary numbers and complex numbers. But for this year, this is all you need to know. Now, what you need to know is that a rational number, or any number in this block here, is a number that could be written as a fraction. If they are decimals, they're decimals that always end or will repeat. And you can tell that any numbers on our table from page 1, any square roots of any of these numbers will be rational. Any cube roots of any of these numbers will be rational, as will these, and will these. Any numbers that don't show up here that I try and take the square root of will be irrational. Any number on here, or on this list, that doesn't show up on this list, for example, 513, his cube root will be an irrational number. So, what do we know about irrational numbers? They can't be written as a fraction. If they have decimals, the decimals don't end or don't repeat. Generally speaking, if you find an answer in your calculator that fills up the entire calculator screen for you, chances are that that actually goes on forever and will be irrational. And for the most time this year, you're going to consider, when your calculator is full of decimals, unless they're repeating, you're going to consider that to be an irrational number. So let's look at the next page. Example number 1. Identify the following as rational numbers or irrational. Use a table on page 1 to find your initial answer and use your calculator to check. So 6. Could 6 be written as a fraction? Sure. 6/1. So because it can be written as a fraction or as a decimal that ends, this guy is rational. This is already a fraction. And remember, the fraction has to be made up of integers. So 5 is on the top, which is an integer. 7 is on the bottom, which is an integer. This is also a rational number. The square root of 45. Look on our first page. Here's our square root list. Do you see 45 showing up here? I see 36 and 49. 45 is not on here, so 45 will be an irrational number, is what I say. And we'll use our calculator to check. So 45 on my calculator, to do a square root, I just hit shift and up here. You can see that that decimal fills up my screen, doesn't have any nice repeating pattern like, 708, 708, 708 or anything. So this guy is irrational. Next one, cube root of 8. On my first page, here's my cube root list. Is 8 on the right side of the equal sign? Yes, it is. The cube root of 8 is 2. So because he's on my list, because his answer is nice, and his answer could be written as a decimal that ends, or in fact as a fraction, this is rational. What about the 4 through to 25? Look at your list. Only the numbers to the right of the equal sign will be rational numbers for fourth roots. And I do not see 25 on here, so he's going to be irrational. And again, if you check on your calculator by punching that in, you will see that it fills up your screen with decimals that don't repeat. This one here, let's look at it. This is actually the square root of 9 over the square root of 121. The square root of 9 is 3. The square root of 121 is 11. This is a fraction made up of integers, which means it's rational. Fifth root of 243. Here's my fifth root. 243 is on there. The fifth root of 243 is 3. So, because this equals 3, which can be written as a fraction, this is rational. Square root of 36. Now think back. When can you have a negative sign inside a root? You can have a negative sign inside a cube root, or a fifth root, or a seventh root, or a ninth root. Any kind of odd root. Any kind of even root will be illegal. What kind of root is this? Well, it's a square root, remember. It has a 2 there that you don't see. This guy does not have an answer. And oddly enough, questions like this that don't have answers, their answers actually fall outside of this, in that zone I was talking about, where we have imaginary numbers and things like that. For this year, though, we just say that. What about the cube root of 125? Well, 125 is on my cube root list. Cube roots can have negatives. So this guy has a decent answer, and his answer is -5, which can be written as a fraction, or it can be written as a decimal. So this is a rational number.